Yeah,
in
for
my opinion.
context for the audience, imagine like posting your own photo to Instagram with something like unique that you made, then seeing other people walking around with it in 2 weeks.
High-level design, it's a good idea to outline very quickly what components you're going to put on the board and how they're going to communicate with each other, kind of like milestone. Non-functional requirements here are 400,000 new SKUs per year.
Yeah, you're definitely going to want something a bit beefier than RepMQ.
Ladies and gentlemen, welcome back to another System Design Nightclub. In this one, we didn't do the 1v1 system design battle format, but we were lucky enough to be joined by a staff-level engineer from OpenAI. In this one, we designed SHEIN, which, for those of you who don't know, is an online clothing store, and we had a ton of fun doing it. Be sure to join the Discord if you want to attend these sessions live and participate in the chat. You can find the link in the description. Hope you enjoy the video.
Yeah, if anybody's unfamiliar with SHEIN, it is a fast fashion brand, and well, why are we picking SHEIN? It is shockingly very, very, very impressive engineering feat. So has a $90 billion valuation. They produced 400,000 unique items a year. Their next biggest competitor only produces 4,000.
That is
So
pretty
just the
crazy.
scale that they're operating on is absurd.
I think one of the most impressive things is how fast they're able to scrape the web and then get the result. I'm pretty excited to dive deep into how exactly a system like this can work, because
Yeah,
technology
for
here is definitely the biggest advantage,
Yeah,
in
for
my opinion.
context for the audience, imagine like posting your own photo to Instagram with something like unique that you made, then seeing other people walking around with it in 2 weeks. I typically like to start with the entities purely just because I try to identify what I call primitives. So basically, what are the core parts of the problem? So just from reading the functional requirements, there's obviously social media posts, so I can just call that content. So content, buyers, profiles are the big ones that
Hmm. So those
stick
are
out.
those let's say, let's split those into two categories of entities, right? So something that is more like related to scraping the web, and something that is more strictly defined relational. So all the
Yeah,
content social media, how do you want to think about the pipeline of seeing the image, converting that to some sort of data, and then seeing how this image would be processed? Like, let's think about like the whole modeling in general. What do you think about something like that?
yeah. So taking this from a business case for it, the cost that we want to look at is one, are we like how are we gauging some metrics? Are we essentially just following something? So say a user has like one photo and or say like 10 photos, but the account is 4 years old and they barely post. But when they do, it really blows up. Do we want to track that pretty
Hmm.
frequently? Do we just want to monitor it by likes? Like, how do we want to do that?
That's a good point. I would say one of the things I'm looking for the most is maybe like a monitoring service to determine the SOT pipeline. SOT pipeline for trends. So my thinking here, the most important thing to consider is that what is trendy. So we need to have a source of truth for trends. So I think that a mix of popular Insta posts, right? Maybe TikTok viral videos, and also what's really important for me to understand is that what is the reason why certain resource or material became popular online? How do we make sure that if somebody saw the dress or the shirt, they upvoted the post because of the dress and the shirt specifically, right? So maybe find um kind of like a goal as well, is to find common patterns between um different brands and styles, and learn from them in kind of more comprehensive way. Essentially, picking all trending videos and then learning what is the reason, what is the new trend basically emerging from those resources. So the
Yeah,
entities to me, yeah. What do you think?
go ahead.
Yeah, I was thinking maybe we should have like a different tiers of entities, right? So maybe like a raw store of all the entities that represent post, and then another layer would represent items available in these videos, and then another layer maybe would be grouping of those items and kind of like build like a layered architecture where in the bottom of your entity stack would be the raw images, videos, posts, and then as you go up the stack, you can see the trends emerge from common elements between the data in those layers. Let's go ahead and split those entities in different tiers. Maybe we're going to have like um raw or like web crawler tier. Um, maybe we're going to have already like maybe shopping tier, and maybe we're going to have already processed here, and then we can see all those components and then see how we can eventually communicate between all the services.
Yeah, this looks good.
Mm-hmm. Okay. All right. Yeah, let me throw in some ideas here and we can see how something like this can look like. So for the raw tier, let's maybe do like a resource entity. So resource entity will be either a form of an social media post. So it's maybe like an Insta post, TikTok video, maybe LinkedIn post is something like this. Maybe for the tier above, the process tier, maybe we're going to have some entities that represent and maybe a video insight object that basically maybe will have some description of what was studied. Maybe
Yeah,
we're Mhm.
for the web browser thing, we're definitely gonna want to keep track of their profile as
Yes.
well too with it, and also their items. Because like what I'm thinking
Oh
is
yes.
essentially just like I'm willing to bet most posts are probably going to follow something like sort of a spike kind of so
Mm-hmm.
first posted um obviously going to start at 0 and then probably show up like probably increase over time. It's going to hit a peak at a rate and then go down with it, so we probably need to only be focused with specific times of it. So like right when something is not posted, we really don't care. So we're probably going to want to find a good frequency, or essentially like when is it going to hit this. So basically check profile every x or y number of days and then stop, because this will essentially go on indefinitely. Essentially, because like what I'm thinking about for modeling for the like for how it is like actually going to work is essentially we track a user, and then post up, then we start tracking for the post. Um, we start tracking for the post, like okay, what's the delta or change for time, and because this is looking at say Instagram or TikTok or something like that, now we're going to have to start monitoring it by engagement, reposts. We just call it engagement in general. So
Mm-hmm.
we're going to have essentially 0, then now because it's increasing at a rate of say like 10% increase every like 5 minutes or something, like how frequently do we need to check that?
Got it. Okay. Yeah, that definitely can be something how we can structure this. So essentially we determine what's the most optimal time for them
Yeah,
to
and that one is going to vary wildly with it. I'm just thinking about it in terms of breaking down the problem of like just in case if anybody ever threw, or if I was an engineer actually building this, uh, if I ever bumped into a problem of do I have access programmatically to where these are stored, like through like an API or through some partnership, or do I not with
Mhm.
it? Because if I don't, that's going to drastically change the design to be more like a web crawler.
Right. That is very interesting because this is not a web crawler, right? We still use the same ideas, but there are some serious tweaks to it, considerable.
Yeah, and because this is like largely focusing on something that is because this is largely focusing on something that people actually wear for it's not like a traditional website where it's easy to scrape content for it and then searching and indexing becomes a fairly
Hmm.
challenging problem. So getting it back and having it be relevant to the user. But now it turns into okay, you have hundreds of thousands of photos that are coming in every single day that you're tracking or watching. How do you identify specifically? Okay, this is the interesting part about it because like it's kind of hard to search blue dress on it and get
Got
something
it.
back without a human reviewer. But that so essentially making sure that those tags are like you're gonna have some you can automate all you want, but there is gonna be a portion of an intervention that is going to need to be involved for some purchases or just some part of the process for it. So basically, just making sure that whoever is you like basically minimize human input from it. And this is where it gets really challenging.
Is that clear how I was kind of thinking about all of those? Here's a guess question to chat as well. So we essentially break down our entity design into different tiers, different maybe subcategories that all focus on providing data structure for certain layers of our architecture. We have the raw web crawler tier that basically just gets the resources. We have the process tier that gets all the video inside and items found in those videos. Then we submit everything to production tier where we manufacture things that human has reviewed and we determine that are going to be trending. Then finally we have the shopping tier where we already have those items. We have the items and prices, and then we have our finally we have all the other entities for buyers, profiles, items, and all the other things not related to data collection. All right,
I
let's
feel
look
like
at some API design. What do you think would be some good APIs to discuss? And one of the things I like to do when I do API design is rather than focus on specific things, I'd like to discuss the overall communication strategy, right? So do you think like a microservice architecture monolith? Are you thinking gRPc, GraphQL, WebSockets, long polling, short polling between components? Maybe you want to represent all the nodes in the system, represent them as a graph and do maybe more sophisticated communication. What are your thoughts on how things should be done over here?
yeah. So I'm thinking for the API end of it, either just working with basic REST API or GRPc.
REST gRPc for which part?
So for the web crawler for it, so for the web crawler, definitely REST.
Mm-hmm.
Then product and so process tier. I could see either one for it, but I don't know. Harry, what do you think? Because
Yeah,
this is more or less just orchestrating.
yes, I would definitely say, I have something very exciting for how we can orchestrate it, something like this. But I think all the APIs, I would say, would be gRPc for communication between microservices. Essentially, the idea is we're going to make sure that every single entity in our design can communicate as fast as possible between each other. So we are reducing latency. We also have more structure when it comes to objects itself. So essentially, we can define protobufs for all those entities. So all entities um, should have a protobuf, and we should um, use gRPc to save some effort on latency and make communication faster. I think generally microservice architecture um, makes the most sense to me. I
Yeah,
think
I think that probably makes yeah I think gRPc makes the most. I don't know. I need to take a chunk of this.
Yeah. If I want to look into, let's say, for backend tier, so this is for like backend slash infrastructure, I think I would say GRPc. For mobile web infrastructure, I would use a BFF that connects GRPc with REST APIs for mobile and web clients. Definitely that's something that I would be pretty interested in, seeing how we can make this accessible to mobile and web as well. I haven't written any protobuf messages in quite a while, but for those in chat, I can do some pseudocode for something like this. Can look like in protobuf message. So this is example of gRPc proto message that we're gonna use in the backend. It's gonna look something like this, where basically you can define type, and then you can do, for example, repeat it, and then you can do price tags, and this is essentially the equivalent of a list. And then you need to define the IDs, somewhat like this. And then, for example, if you remove something at ID 1, then you need to reserve this ID because, for backwards compatibility and stuff like this. So for this, for example, how gRPc would look like in this game. So right now I picked just one thing to look at. So internal item from this entity right here. And then gRPc client would need to create this object, and this would be passed around between the APIs. Maybe this would be named something like internal item request object, and then there's going to be another message that is going to have internal item response and stuff like this, and it will have the same kind of protobuf message as we've seen, and you would be able to make calls via gRPc client and navigate on something like this. Yeah. Oh, it looks like I've got my product pretty correct, and somebody posted in chat, and I have a pretty good memory in how something like this could look like. Yeah. And when you define the APIs as well, you would essentially do something like this: service, and then like item product service. And then what you will do is define the API by saying RPC, and then maybe get internal item. And this API would take something like internal item request, and then return a response.
Right. That is good for me.
Yep. And essentially, this is so much nicer because you can, instead of relying on JSON for sharing your data and passing your data around, gRPc requires you to define everything in those messages. One good tip: if you guys are about to start your own tech company, go ahead and create one GitHub repository where you're gonna have all your profiles, and just store everything in one GitHub repo. I promise that will scale. And then everybody can obviously import products they need for their projects and stuff like that. That's, I think, for the API and communication layer. One of the best ideas that came to my mind is to come up with milestones for your high level design to prevent you from going down a rabbit hole. Essentially, you really want to come up with like 5 things you want to talk about. And that's kind of why you have functional requirements as well. But sometimes, maybe for high level design, it's a good idea to outline very quickly what components you're going to put on the board, and how they're going to communicate with each other, kind of like milestones, especially for a problem that has so many opportunities to go down a rabbit hole. So even if you have high level design functional requirements, for high level design, I think it's a really good idea to come up with milestones. Denver, have you seen anything like this thrown around, or maybe something similar?
I haven't, but that would be phenomenal for very experienced candidates and very specialized candidates.
Absolutely. Kind of like merge high level design and deep dive section into one, but then have crisp milestones to show your technical leadership. When I see candidates who are going for staff level or above, it's much less about what they know. In my opinion, it's more about their technical leadership. Are they able to become like a force multiplier where they can communicate a very clear vision to the rest of the company and show those milestones, how everybody should work together to achieve them. First milestone, what if we have something like ML model fleet that allows us to process the data in storage and deliver insights. So the data expectations I have at this level is, for example, black dress and maybe like a description uh, of the specific dress, and then maybe like a metric. Maybe we can derive specific metrics like seen number of times, and then per week, maybe per month in the last like few months. Maybe we can also derive things like how many times it was upvoted. What times it was upvoted. Percent times present and stuff like this.
Yeah,
Uh,
because what I'm looking at for this one is essentially something like there is going to be like a little bit of a lull and stuff, and it's like, okay, so if say something like doubles in an hour and it goes from like one like to two, it's not really going to be very useful. But something going at a steady rate from 0 to 500 to, and say 600, 900, 1500, 3,000, 10,000, etc. With it, that's probably going to be a lot more interesting for it. So, ByteDance is a really cool service for this one. I think it's called Monolith. Yes, it is essentially a recommendation system, but they do have a
mhm.
pretty good paper on exactly how their algorithm works. So essentially, a like gets 1 point, share gets like 10 points. Trying to think of the TikTok paper that I read. A share gets like 10 points with it. Follow is like 60. So they clearly have something that is continuously monitoring this to essentially pick it up with it, like actually tracking that delta over time. So I think the delta spikes is what we're going to essentially want to track, and then have something where it's like the first, say, 50 posts or something, some sort of average with it, or like 100 points for engagement or
Mhm.
something we don't even care about. So until it hits a certain flag or something, we're not going to pass it off to a human reviewer,
Mhm.
like some sort of a
Yeah.
threshold.
Would you say we need to build like a manual review service where we maybe have
So
some agents?
essentially something to essentially something where only the most interesting pieces, something or stuff that has the highest score or highest
Right.
change, like some sort of rules to it, is getting presented to somebody. Because
Yeah.
we have this really cool scraper that's able to process all of this stuff. And well, the whole thing of scraping is uh, in crawling is you really only focus, like, yeah, getting the data and maintaining and watching all that is a huge challenging part of it. And you could spend an entire career there. Then, okay, you have all that data, and now you need to reasonably search it, because having a massive bill from AWS really doesn't help anybody.
Right.
So you have to have an
And
efficient way of searching
yeah.
that. Likewise, you spend an entire career on that.
All right. So we have manual review service agents, human, maybe AI agents as well to review the recommendation. And then we have maybe the manufacturing, um, kind of like a manufacturing layer to produce items, right? So I think it's we're gonna have like a microservice that sends those requests, and you know we would like to do something about it. So that's our manufacturing layer right there. Then finally, um, for M5, I think we should have all the items indexed and added to our shopping app. So I think that's going to be the last step. Yeah. What type of database are you thinking for storing this raw data?
So the database for what I'm thinking about storing the raw data in is I'd probably stick with how much do we think that we should tap this. It is going to be very, very, very read heavy with it. And we're essentially going to be going through the entire top of the database all the way down to the bottom
Mm-hmm.
of it.
Yeah, that's an
So
interesting
yeah, because if we're not
observation.
going to be watching every single person on TikTok and looking at every single post on Instagram, that would be massive.
So
So
how do you decide what are you gonna write to your database? What are the criteria for writes?
so the criteria for rights for this one would honestly just be somebody adding, hey, this person has a great style, watch their profile. Or then
Mm-hmm.
essentially automating that to get checking to essentially check X. Like I can't imagine that it would be more than like say 15 minutes
Okay.
at the most. But I could see a huge leeway just because don't post content that much. So we
Okay.
can't afford a little bit of like we don't need to have data available instant. But we do need to essentially hold on to this data for a while since like that's our entire moat.
Got it. So for people wondering, we're operating at a pretty massive scale. So instead of thinking about traditional requests per second, we have measured that the right non-functional requirements here are 400,000 new SKUs per year. So that comes out to be almost 1,000 or over 1,000 elements created per day. So we need to deliver at least 1,000 different elements to production. And if we assume that maybe let's say only 1% of elements we detect are worthy of producing, we need to have a pipeline that has 100,000 fashion items at the top of the funnel, and then to the bottom of the funnel to production tier, we're only streaming 1,000 items a day. So we need to process 100,000 fashion items per day, which comes out to be about one fashion item per second. So just to recap very quickly, we have the web crawler infrastructure here. So maybe we can even mark everything here is like essentially everything related to crawling the web, tagging the web, and crawling the web, and data data gathering.
Yeah, I would break it down into one more part too. So actually performing this calls
Mm-hmm.
is a service with it. So essentially just kind of like black boxing how it is performing that. So we're essentially taking from the top of the database to the bottom of it to check. So this is going to be what's actually like firing off the request and then something to essentially crawl through those feeds. So you're going to have, so crawl service. This is where I would use just some sort of a caching mechanism to
Mm-hmm.
essentially distribute out the load if there's any sort of blocking
Okay.
with it. So say we do need like a full like RPA approach and we don't have access to their API. So like Netflix famously does not have any sort of developer access and makes it very painful.
Mm-hmm.
So does LinkedIn. So we're going to need to essentially spread that out, and then it turns into a game of whack-a-mole. So essentially, like caching, like where does this need to actually go for it? And I would drop like another queuing service into it, like in between this. So like you can use something like RabbitMQ, just because we're not going to really have a ton that we're going to be working through with it. But for simplicity's sake, simplicity's sake, RabbitMQ is probably going to be the best fit for this
Okay.
one. So essentially, I'd kind of add this like more as like a sub.
Mm-hmm.
Yeah, then from that content, so essentially we have on the web somebody's profile, then getting back all the information for it, and we're going to essentially carry that back for like the posts that we're watching to update it.
Got it.
So
Okay.
then we have that stream coming in, coming back in an ordered way. So if somebody blocks the post, something's down, it's not going to break everything.
Some people are curious, why do you prefer RabbitMQ over SQS or Kafka?
Largely just because this would take only like 10 minutes, like launch this in SQS. I mean, not SQS, RabbitMQ. So it's just simplicity's sake, just because like we don't really have a ton of creators who are watching for it, and we have like a little bit of leeway given the time that we're actually like fetching stuff. It's essentially just like a fancy sorry, kind of lose my voice a little bit. So essentially, just because we do have that like 15-minute lag that we're allowed for like an SLA, it gives us a lot of leeway, or like it gives us a lot of leeway for it. And 100,000 isn't that bad
Got
with
it.
it. So like on the actual shopping end of it, of somebody like doing a transaction where now you're operating on a scale of millions, or like per hour, yeah, you're definitely going to want something a bit beefier than RepMQ for it. But given the limited amount of data, and the fact that this is extremely predictable and automated, I think it fits like well within the SLA for it.
Yeah, that's a good answer, I think. All right, let's wrap things up. I
Yeah.
think
One more question for it. So why would the forward queue, or how is the forward queue
you
implemented?
implemented. Yeah,
Yeah.
that's a
So
good one.
when you're passing something off to a service that's essentially going to hit an API endpoint, or like go to a certain website, you're going to want them to essentially be ordered with it. Then if say access is down for whatever reason, that you don't want to have any lag in that data. So having some sort of queue to essentially pop back in if a website's down or redirect it, uh, you're gonna need it. I don't know if that like directly answers the question.
Yeah, I think it's a pretty great answer.
Yeah, because there's the whole why do we have it, and then how's it implemented. And implement is a little vague.
Yeah,
But,
100%.
so if you want to like type a little bit more, I can like totally go into that. But
Yeah. So just to recap, all the data would be thrown in Cassandra, where we'll capture with the CDC to the ML service that will do some provide some insights on what's in there. So an example schema would something be like the um, item ID, and then the item description score of how well this item has performed in the individual aggregation layer, and why we think it's interesting. Finally, we have some final level aggregation that more holistically looks at the whole picture. And then what this recommendation level info would do is they would pass data to the manual review. So something like a manual review process over here. Let me just make sure this is a like this. So this is a manual review service. So essentially, this is where we would determine whether or not we are going to be launching this particular item. So we're going to see maybe this example of white dress and see, hey, we have white dress with this description. Should we manufacture this? And then depending on what the answer is, we will shipping this basically to a manufacturing microservice. And here we would have all the things produced basically from here. And then when the manufacturing will be pretty much conducted, we don't really have much of control over this. And then finally, we'll have all the things delivered to maybe the shopping ingestion microservice. So what this service will do is that we'll basically take the data on the newly produced item. So maybe like an S3 URL for pictures, price, item metadata, and then this shopping ingestion microservice will go ahead and maybe call the um, S3 bucket. So we will have S3 for images. Then we'll have maybe something like a CDN that will be essentially delivering those on the consumer side of things. For the microservice and it probably will should write to another table. So for shopping and consumer side, consumer data store, what type of database are you thinking about? So we have quite a few options. We have CRDB, we have Cassandra. What do you think about the database we should be using here?
I personally don't know off the top of my head enough about cockroach to have anything to like make it sway anything over Cassandra
Mm-hmm.
with it. Is there a use case that I'm missing for cockroach?
Yeah, so essentially you can have a SQL-like schema. So what CRDB provides is a SQL-like schema on top of key value store. So essentially you get performance, you have strong availability, strong consistency, high availability, very pretty good scalability. And then what you have, this is essentially what you have for Cockroach. And essentially one of the great things about it is that you're able to produce all of those you have all those features, and then most importantly you have a SQL schema. So you can have joins, tables. You don't have to worry about the query, right? When you have a SQL type, when you have a SQL table, you can essentially query the data however you like. There are some downsides to it. It doesn't really scale that well, and then while Cockroach takes care of scaling in some way, it becomes a problem when you want to do some queries that span multiple nodes. So a downside of Cockroach is doesn't perform well on queries that span multiple nodes, and that's where Cassandra, I think, is one of my favorite DBs because it's pretty scalable as long as you know how you're exactly going to query the table, and when you understand the difference between normalized and denormalized data and how exactly that would be structured. I think Cassandra is a pretty solid choice. So if you would want to, for example, store data in Cassandra, what you will have is something like item by order, something like this, right? So you have a table that is already predefined to query item by order. And then you have another table, maybe order by collection, or maybe let's say item by collection. So we essentially have a wide column sort that is grouping those tables together, and then they will have similar data, but they represented in a different way. And the reason for this is because Cassandra doesn't have joins. So that's why when you have a use case that writes to Cassandra, you need to actually write batch queries in batches to different tables, because those tables essentially were created after engineers determined how they should be queried. That's the whole idea behind Cassandra denormalization. You don't do joins, but on the flip side of not having to do joins, you need to really think how Cassandra should define the data schema so it can be actually used and stuff like that. So that's kind of where the challenge is at. I personally really prefer Cockroach myself. I haven't directly worked with Cassandra myself, so I'm not an expert there. Um, but Cockroach has served me well over many projects, and I really appreciate not having to worry about quorums and tunable consistency of Cassandra and all the setup. And I really like Cockroach. It's one of my favorite databases. What about you?
Yeah, is there anything with consistency that we need to think about?
So actually, consistency is a scam. Like you actually don't need strong consistency. It's a pretty aggressive statement, but in reality, we have evaluated a lot of use cases, and most of the time, when you think you need strong consistency, you actually don't need it. And there are many examples in many real projects where consistency just causes um, outages and really hurts availability. Most companies actually prefer not to have things strongly consistent. And I don't actually think I can come up with an example where a configurable consistency of quorum is not good enough, right? I actually don't think there is an example of something like this. And most in most cases, last right wins as a strategy for handling any issues with replication should be a good enough strategy. Even if you think about use case like one rider should be only assigned to one driver for Uber trip, for example, right? In that specific case, you you don't really need strong consistency. Quorum should be enough um, to handle it most of the time. At least that's how it was in most of my projects. What do you think?
Yeah, I don't really have too strong an opinion about Cockroach. I personally haven't worked with it, and also haven't had the time to actually like have a dive into what makes it unique. I literally just know the name for it, but I feel like in most of these cases, Cassandra is going to work pretty well for this, because largely we're actually moving to like getting everything out and anything to do with shopping in general. We're going to want to track all that. We're going to make sure that everything is consistent across all nodes, and also I really like how Cassandra handles fault tolerance
Yes,
and faults.
and yeah. Also, another good thing about Cassandra is append only writes. I
Yes.
think append only writes just makes so much sense to me. I don't really understand how other databases really have to worry about like updating previous rows and stuff like that. I just feel like it creates so much contention specifically because you're not doing append only mode, and append only mode is so easy. I personally haven't really discovered any downsides of append only writes. It really seems like a way to go. So I definitely like Cassandra a lot as well. So as long as you're comfortable with having a lot of tables that have those kind of weird names like item by order or item by collection, I'm totally cool with going forward with Cassandra.
Yeah, and I feel like because a lot of like basically Shan is a really sophisticated web crawler and data analytics company that just happens to sell clothes.
Yeah,
So considering a huge amount of the moat is in the data and the actual analytics
100%.
part of it, one trade-off that you can argue is like, yeah, there are some weird names that can lead to some breaks along the engineers just because it can be a little annoying to work with some of the names. But I feel like considering the importance of the data end of it, this is something where you could easily tell your engineering staff, like, hey, suck it up.
Mm-hmm. Yeah, I'll definitely say this should be like a job actually that um maybe also based on CDC. What I would like to actually do is two things. I would like to have whenever something write something to a database, I'd like it to go to Kafka, and then for every single change feed that we capture, so change feed of everything we capture from what is actually reading to the store. So I would like to do a couple of more things. First of all, Kafka would write data to Snowflake for analytical purposes. And I would also like to notify other microservices in our shopping org that would do some interesting stuff. So maybe we're going to have a notification platform in our company, and this notification platform would send out a notification to consumers who are really interested in this type of order or type of item. Another thing I would be interested in maybe some other microservices, right? So other services um, that would be interested in learning about the new data and new deals that are available. And this Kafka would have a topic of ingested item ID. and everybody who is interested to subscribe to this topic can learn from this data and then do some processing on top of it. So I think that's actually a pretty good example of how Kafka is used in large consumer apps to learn from anything new thing created, and it indeed acts like a broker in a sense, and allows other services to learn from this and process it.
So for I think somebody described with the of being able to like actually like reverse image search to find a similar item in store. That adds kind of an interesting layer to it. Sorry, I'm like completely backing up
Mm-hmm.
this one. So instead of like purely tracking social media posts and that's it as a source of truth, I bet there's an interesting angle from actually users uploading their own images
Yeah,
as
I
well
think
too. So if you have a like say a sudden spike of like I don't know 10,000 people or something all searching for the exact same thing.
that would be pretty interesting as well.
Yeah,
But yeah, I think we're actually at time for the design, so I think we covered a lot. It's actually
yeah,
pretty
yeah.
huge
It's
design.
massive.
Yeah. We did this together in just an hour. Maybe some last words, like a summary of everything we did. So kind of like walk through the entire architecture, some of the core decisions we've made and why we made them. So we can summarize everything.
Yeah. So we're essentially starting with a cron job that's going from first to last with it in front of a forward queue.
Mm-hmm.
Pushing that to a crawl service, then essentially having a DNS cache to operate essentially kind of like a load balancer
Mm-hmm.
or just something to essentially check to make sure that everything is working with it because crawlers at any sort of scale can get a little finicky. That is passed along to another database, then passing that along to a like to essentially act in the middle of it, then having a change feed to essentially pass along to an ML service, which is going to take some of the raw images or take some raw images along with some of the data for the posts and growth and essentially just delta and writing that to Snowflake on the recommendation level. Infra, we're going to have something query that pass it along for manual review because we haven't all been replaced by robots yet. There, somebody will essentially give a like thumbs up or down. If this needs to go into manufacturing, then that enters into make essentially those lead times and start that process. And we're passing it along. We actually, hey, we have this made now. We need to actually list this. So this we're going to just pop into something to list it on our storefront so we can have like straight for payments. We can do everything at Shopify. This is where we can black box a lot of it. The shopping and consumers, we are just going to keep in something like Cassandra or Cockroach. Then we are going to essentially pass that along to another Kafka instance to essentially serve for notifications, other services, uh, keeping all of the shopping metadata, et cetera, et cetera. And then, as always, you're going to put all the images of what you are selling into a S3 bucket and a CDN.
Yep. All right. That's a pretty fantastic summary. So we can pause right here. And yeah, this is it. Thank you so much, Denver, for your time doing this design.